So some known configurations: a 5-cylinder 2-stroke engine, inline engine, 5-cylinder 2-stroke inline engines. So here the firing order is 1, 4, 3, 2, 5. So this is the firing order. So 1, then 4, then 3, then 2, then 5. So this is these are the angular intervals, and always remember the angular intervals are computed based on the firing order. So first 1, then 4, then 3, then 2, then 5. So after 1, 4 is fired, then 3 is fired, then 2 is fired, then 5 is fired. In any direction you can show. You can show it in this direction or in this direction. For the sake of analysis, it would be same. And since it's a 2-stroke engine, so one complete revolution is 1 cycle. So the angular interval is 72 degree. And first you have to show 1, crank 1, then 4, then 3, then 2, then 5, according to this firing order. Then the xi is the distance, and the leftmost cylinder is taken as the reference. Leftmost engine is taken as the reference. So cylinder number 1, 2, 3, 4, 5, and the angles are: first one is fired to show 0, then 4 is fired so 72, then 3 is fired so 144, then 2 is fired so 216, then 5 is fired, then 288, then again 1 is fired. So this order is very important, and these are the distances. So 0a, 2a, 3a, 4a. Now cos phi, sin phi, xi cos phi I, xi sin phi I. So these are the sums. So this is a full primary force and couple. So if you sum this cos phi, you would get 0. If you sum the sin phi, you would get 0. That means primary forces are balanced. But if you sum this, you get this. If you sum this, you get this. So the secondary couple moment is there, which is this cos theta. I don't know why we have put 2 theta. This is cos theta. So here there is one mistake. This should be 1, not cos 2 theta. This cos theta, not sin 2 theta, but only theta. And this is a secondary one. For secondary, these are the twice of these angles. Whatever you have written here, you have to just multiply it with 2 and write it here. Then same procedure: cos 2 phi, sin 2 phi, x sin 2 phi, add. So forces are balanced. So secondary forces are also balanced for this engine, but this term is there. Here cos 2 theta, sin 2 theta is okay. So this is all about the state of balance of a 5 cylinders 2-stroke engine. Here we are not showing any method to balance this engine. Now this is a very common engine, that is 6-cylinder 4-stroke engine. Here 4-stroke means 2 revolution, and the angular interval is 120 degree. The firing order is given. So 1, 4, 2, 6, 3, 5. So first 1, then with 120 interval 4, then 120 interval 2, then 120 interval 6, then 120 interval 3, then 120 interval 5. So this is how the crank diagram is drawn. Now you can draw tables like this, you can construct tables like this, or you can draw you can do it graphically by putting masses at the crank tips. For the primary, 1 is along here, so 1, then 2 is along here. This is the force polygon 2, then this is 3, all forces are equal, so 3, so the angles are 60 degree, so this is a um, uh, all sides are equal. So now here this is 4, this is 5, and this is 6, so it comes back where it started from, and the primary forces are balanced. But while computing the moment, this is 1 will not give any moment, so to start from 2, 2 will give you moment, and here only A, then 3, 3 will give you moment, but it will be twice this value, so it will go up to this, then 4 will give you moment, so 4 this, so here it will be 3A, and here you will get 5A, 3A, then 4A, so this is 4A, so it will come back here, then uh, 5A, so it will again 5A for 5A for this 6, so it will again come back here. So you can draw this triangle, and you can convince yourself that it is again coming back where it started from. I think that it is not, since this is not according to scale, this should come not up to here but a little more, and then 3, and then when you take this as 4, it will come back just vertically downward of this point, so then you just join this. Good. Then secondary crank. Secondary crank, you have to draw the secondary crank from the primary crank. Primary crank, remember here the crank lengths are r by n, and the speed is twice omega, and the angles are twice, so 1 0, so 0, 2 into 0 0. For 3 it is 120, for here it would be 240, so 3 is here. For 2 it is 240, so 480, so 2 would come here, 2 has come here. 6 0, so 6 0 into okay, 1 2 3, then 4 is 120, so it would go here, that is 240. Then 5 is 240, so it would be 480, so 5 will come here. Also you can, from this side also, 120 and 245 would come here, 6 will remain here. So this is a secondary crank diagram, this is a secondary force diagram, very similar to this, and this is the secondary couple diagram. All force, in while drawing the couple diagram, you remember, though the couple is actually perpendicular to the plane of the inline engine, we are showing all the couples along the forces. So since here the distances are all positive, all the couples are along the forces, but if the distance is negative, then the couple would be just in the opposite direction of the force. Anyway, so force couple is also, no, sorry, for 1 will not be there, from 2 it will start. 2 force, so 2 couple in the same direction. 3 force, 3 couple would be in the same direction. 4 force, couple would be in the same direction while drawing, but actually it is not. So 6-cylinder engine, there is a complete force and couple balance for both primary and secondary. So you must remember this. And this is a 8-cylinder 4-stroke engine. In 8-cylinder 4-stroke engine, there is actually two 4-cylinder engines. One is 1 7, so this is C 1 7 1, this side is 1 2 7 and 8, these constitute one engine, and 3 4 5 6, this constitute another 4-cylinder engine. 3 4 5 6 constitute one 4-cylinder engine, and 1 2 7 8, this constitute another 4-cylinder engine. So the firing order is 1, so 1782 is the firing order. 1782 is the firing order for the outer 4-cylinder engine, and 3564 is the firing order. 3564 is the firing order for the inner 4-cylinder engine. And the inner 4-cylinder engine, the plane of the outer 4-cylinder engine and the plane of the inner 4-cylinder engine is 90° apart. So if one makes theta with some reference angle, then this 3 makes theta plus 90° with that reference angle. So you know, for 1, 2, 7, 8, only one unbalanced force, secondary unbalanced force is there, which is this. And if one makes theta angle with the reference, then it is cos reference line, then it is cos 2 theta. Then for 3, 4, 7, 3, 4, 5, 6, it is, since this angle is 90°, the secondary force is cos theta plus 90°, which is actually this. That means the secondary force for the outer 4-cylinder engine and the secondary force for the inner 4-cylinder engine, both are acting at the middle, both are acting at the middle, they cancel out. So there is no net unbalance, so no couple unbalance, no force unbalance, both for primary and secondary for a 8-cylinder 4-stroke engine. So we have seen two popular inline engines, the 5-cylinder 2-stroke, 6-cylinder 4-stroke and 8-cylinder 4-stroke. So let us stop here for the time being.